3.
Children, in the last class I had uploaded video for you.
Yes,
Did you see that class?
Yes, miss.
Many are there who did not watch that class. You have seen.
Yes,
So what are the three things that we learnt in the main three things we learned? What is it? What did we learn about?
Convection.
What is that? What is convection, convection and radiation? Different types of? Huh? Yes, different types of? Heat? Yes, it is different types of heat transmission. Isn't it? So in heat transmission, there are three types of heat transmission we learned. Which are the three types? Conduction, convection and radiation. What is conduction? Let me see whether you understood. What is conduction? Yes, that is in a solid. Conduction happens in a solid, we know, isn't it? In a solid, in a metal piece, we know in a solid, molecules are tightly packed. Molecules cannot move that side and this side in a solid. It is tightly packed, it cannot move. So what happens when we heat? At one end, what happens? The molecules in that end will get heated. And slowly, it will transmit the heat to the neighboring molecules. That is, if Neha is one molecule, if Neha is heated, Neha will transfer that heat to Pooja. If you are sitting close together, that heat will go here, then like that, it will pass on without change. Molecules will not change its position. Understood? But instead, one molecule will get heated. That heat is given to the next molecule, like that, it will reach at the end of the substance. So one end if you are heating, we will. So if you are holding a iron piece and heating, after some time you will feel heat at the end of the iron piece. So how does it reach here? From there the heat is being transferred through the molecules without molecules changing its position. That is called as conduction. What is convection? Convection happens in which one? In liquids and gases. So when we heat a liquid, what happens? We know the molecules in a liquid are loosely packed. In gas also it is loosely packed. So what happens to the molecules? You take a tumbler of water. What happens? When we are heating underneath, what happens? The molecules of the water which are underneath will get heated first. When it gets heated first, what will it happen? What will it do? The hot molecules. The hot molecules of the liquid will rise up. It will rise up. It will go up. When it goes up, what will happen? The cold molecules of the liquid will come down and take the place of the hot molecules. There it will get heated. So it is moving like this. You saw that color is moving like this. The sawdust is moving like this. That is just for you to understand that the molecules are moving, that the water is moving. If you don't put color, you cannot see the water moving, isn't it? So it will move. That is, hot molecules will rise up and cold molecules will cut down. So it will go round and round. That is, it will move and molecules will move and transmit the heat everywhere. Same way in the gas also, when we saw that incense stick being burning, isn't it? Smoke is going up. And then again that cold smoke will come through the hole and again it will go up like that. It will rotate. So there also the molecules move about and what is that? Heat the entire area, entire liquid. Understood? That is called as convection. So what is convection? The transmission of heat by actual movement of the molecules in a liquid and a gas. Now what is radiation? There is no mode. There is neither liquid nor a gas. What is that? Heat will come directly and touch. Understood? Heat will come. There is no mode. Does not use a solid. It does not use a liquid. It does not use a... Here the heat is using either a solid or a liquid or a gas to get transmitted. We are feeling the heat, isn't it, when we are getting. But here in radiation, the heat rays, it's not using any mode. Neither liquid, neither solid, neither gas. It is coming directly, that is from the rays from the sun. Directly it comes, we get hot. When you sit near the fire, you go near the candle. If I keep a candle, if I go keep my hand near the candle, I can feel the heat. That is called as radiation. Without any mode, directly the heat comes. Okay, that is called as radiation. Sitting near the fire, when you are burning in the wooden oven, you go near, or you are standing near the oven, electric oven, you go near, you feel the heat. That is called as radiation. So these three things, did you understand?
Yes,
very clearly. Convection happens in solid. That is without the movement of the molecules from one to another, like that it passes. Convection is by the movement the molecules move. That is solid and liquid. Sorry, liquid and gas. It moves and heats the entire thing. Understood? Entire substance. That is called as convection. Radiation means there is no mode. Directly we feel the heat. That is called as radiation. So I hope this much is clear for you.
Yes, ma'am.
Now the next one, we know when we heat a substance, when we make rice or curry or something, we cook in the morning. Afternoon when you go, what will happen? If you keep in the same vessel, what will happen? It will become cold, isn't it? The time to eat, what have to do? Again we have to heat it. For us not to lose that heat, what all things can we do? You can put in a tight container. What else does your mother? If your mother is going for work, you have your grandparents at home, they cannot take the vessel and heat it or put on the gas. Or sometimes now during COVID season you are alone at home, isn't it? That time your mother will not ask you to put on the gas because it is dangerous. So what does she do? You need hot food in the afternoon. So what does she do? Yes, you put it in a casserole, isn't it? Why do you put it in a casserole? Yes, afternoon also when you open the casserole, it will be hot for you to eat. Now water. What do we do? We put it in a flask. What is that called as? It is called as thermoflask, isn't it? Thermos flask. Now why does these type of vessels retain the heat? How does it retain the heat? Some vessels are there like casserole, then in the textbook we have seen, isn't it? What is that? That hot case is there, casserole is there, flask is there. These type of vessels are the ones which do not allow the heat to go out. That is, the heat from that vessel, when you close it, keep from inside, the heat doesn't get lost due to convection, convection and radiation. Heat is lost when there is convection and radiation, heat gets lost. So all these three things does not happen in that type of vessel. So we need to know what is happening. How does these type of vessels or the flask, how does it retain the heat? We need to know, isn't it? Yes, for that we will, let me see if we can get a video so that I can show you.
Is used to keep things warm and cold. It consists of a double-walled glass flask having vacuum between the walls, kept inside a metallic case with cork supporters. The outer and inner surfaces of the glass flask are highly silvered. The mouth of the flask is fitted with airtight cork. The vacuum between the two walls of the flask prevent heat transfer by conduction or convection. The silver coating of the walls of the vessel reflects back heat radiations. Thus, heat by radiation can neither enter inside nor go out of the flask. The airtight cork, which is bad conductor of heat, prevents any loss of heat by conduction or convection. Some heat may be transferred by conduction through thin glass walls at the neck and the poorly conducting cork.
Is it clear? Huh? Do you understand what it is?
Yes, ma'am.
That is?
An excellent example.
That is? Look into your textbook. There you can see the picture on page number 122, isn't it? What can you see there? You can see the picture of a thermos flask. So what is there inside? Inside the flask is made up of glass vessel, isn't it? And the glass is double coated. That means 2 layers of glass are there. In between these 2 layers there is vacuum. That day in the last lesson when we learned what is vacuum, isn't it? There is no air nor liquid. That space is called as vacuum because inside there is nothing, neither air or. So there is vacuum between the two layers of glass. Then inner wall is coated with silver. If you look inside the flask, you can see silver color, isn't it? That is because the inner walls of the flask glass is coated with silver. So what happens there? That is because the glass is double wall, outside it is plastic and all that. So what is that? The cork is also there. So inside the heat substance, the heat does not go out through conduction or convection. Then because the silver is there, we know in radiation when we were learning, we saw the radiated heat, if it strikes on a smooth surface, it will reflect back. So the heat from outside, what is coming, when it hits on the silver, it will reflect back. It does not go inside. So their heat loss is not there due to conduction, convection or radiation. Understood? If conduction and convection happens, then the heat inside will go out. So the cork is also there. Tight cork inside the lid is there, no? Which we turn and tighten. So inside that there is a tight cork which does not allow the heat to go out. Neither the heat goes from the side. So that is why it is tightly. In a casserole also, if you can see if the casserole breaks, you can see inside and all layered with thermocol and all that, isn't it? So there the heat is maintained inside and it does not get lost due to conduction, convection and radiation. That is why the heat is retained inside the vessel. Okay, so that I hope it is very clear for you. Thermos flask, what is the use of the glass vessel and the lid? We saw in the video. Glass vessel and the lid, what is the use there? Prevents heat loss by conduction, isn't it? Vacuum between the double walls. Vacuum between the double walls. Prevents heat through convection. The inner surface coated with silver salts. Prevents heat loss through radiation. That is what you have to write there. Okay. Now, next one we are going into thermal expansion in solids. What do you mean by thermal expansion? Thermal expansion. What is the meaning of thermal expansion? What is thermal expansion? That is solids expand on heating. That is called as thermal expansion. Means when you heat something, it will expand. So for that we are going to, for you to understand, we are going to do a small experiment. Okay. You have to listen very carefully. I have a candle here. Candle burning here, and I have made a circuit. You can see here there is a battery. I have kept a buzzer. Then the wire is connected. Now here I have a small copper plate. Okay. And here I have a copper wire. I have attached a copper wire. And that copper wire is attached to the circuit here. So there is no switch here. Now you have to take this as a switch. Okay. Now this is not working, isn't it? Now this is kept here. These are not touching each other. That is why it is not working. So this you have to consider it as a switch. Now what we are going to do is we are going to heat this copper wire and the copper plate. Small copper piece I have kept here. Okay. So we using all the other circuit is connected, but this is an open circuit. When does the circuit work? When it becomes closed. So I am going to heat this. I am going to keep this here and heat the copper. You have to listen. I am going to heat this. Okay. You cannot see. So if the solid expands, when heating, what will happen? Now those two wires are not touching it. Those two things are not touching each other. So it is an open circuit. If it expands, what will happen? It will touch each other. That time it will become a closed circuit. This has to work. Okay. So we will see. Close it. Here children. Now I am heating here, isn't it? So when these two things are touching, battery is gone. You can hear the beep, isn't it? Why is it so? Because when I am heating here, what is happening? That plate, what is it? That metal plate, that is that copper plate is expanding, and it is touching each other, isn't it? Now when I am taking this off, it will stop. Why? When the heat is going, it is contracting. It becomes, isn't it? It expands on heating and it contracts on cooling. Okay, this is called as thermal expansion in solid. What happens to the solid? A metal piece which conducts heat. It expands on heating. So that is what is happening. When it is expanding, both the metal pieces, that is the wire and the metal piece, is touching each other. So the circuit is becoming complete and the sound is coming. When I am taking it off, it will contract. Okay, and then the sound will start. Now it is a closed, it is an open circuit now. So when we go on heating, when it touches each other, it will start working. Understood? So this is called as thermal expansion.